Hey everyone, this is Jay again. This is part 2 of basic composite technology. In the first part, we discussed some basic definitions. We discussed the reasons why composites are such a desirable structural material, and the advantages and the few disadvantages to composite technology. And we led up to this point. At the point we are now, we need to start discussing the components that make a composite part. Well, one of the most important components, of course, is the fibers that we're going to use. So I've got a few things here in front of me that are commonly used, not only in aviation composite parts, but marine, wind generation blades, and now even a great deal of architecture starting to be made out of this type of material. So let's discuss the materials. The fibers commonly used in composite parts are going to be one or a combination of these materials that I have in front of me. Now, this first material here, a lot of people are familiar with because it's been in use for many decades for a lot of reasons. This is fiberglass. Now, fiberglass that you would use for boat repair and fiberglass used for aviation work differs a little in composition. The fiberglass we use falls into one or two categories typically. It's S-glass or E-glass. This happens to be a piece of S-glass. The thing that differs between these two types of materials is what's mixed in. Now see, fiberglass is made from silica. Silica is widely available all over this globe. We're talking basically about really clean sand. If we melt that down and we draw it out into individual fibers, then we can weave those fibers together to create this type of cloth. Now, it seems to me it's kind of hard to understand how we could take glass and create something this flexible out of it. But remember, because these parts are being pulled very thinly into thin little fibers, it allows it to flex. Now, S-glass is formulated by mixing some different elements into the silica. S-glass, I like to remember as S for structure. Now, the fiberglass that I have here in my hand is common, and it comes in a lot of different styles and weights. The basic composition is going to be the same, but it's always important when we're doing repair work or in manufacture work that we select the right fiber and the right style. See, components of composites are identified with style numbers. And if you've ever worked with aluminum, we know that different alloys are identified by a number system. A common alloy that we use in aviation is 2024 T3. So that identifies the exact alloy. So how would I identify the exact fiber? Very similar system, but actually a little easier to learn because the style numbers are typically just a short number that would indicate what fiberglass is the right fiberglass. We can always find that information, or should be able to, in the structural repair manual for the aircraft that we're working on. So the idea is we'll select the right fiber to do the job. Fiberglass is our first one. It's a wonderful material. It was around for many decades, but fiberglass had some limitations. As far as aircraft use, initially it was used to make some aerodynamic parts that weren't necessarily heavily loaded. They didn't have to carry a lot of stress because fiberglass alone wouldn't necessarily build a part that could carry that same stress. But it was a very useful material, and it is still in use, even in more advanced composite structures now. So when it comes down to the fibers themselves, I always like to start here. It's been around a long time, and it'll continue to be a part of composite parts, probably for a long time. Now, I will say this is kind of a note. The fiberglass and resins that have been used for many decades for boats, car bodies, like the Corvette, That's a little different approach and a little different materials than we use in aviation. So if you use boat repair techniques on aviation composites, what you'll end up with is an unairworthy repair. So let's avoid that and always follow the aviation materials, chemicals, processes, and procedures so that we can make a good, safe, airworthy part. Now, our next fiber that I'd like to take a look at and look closely is carbon fiber. Many people are familiar with carbon fiber too because it's used in a lot of industries other than aviation. Carbon fiber to most people means performance. We see carbon fiber used on motorcycles, high-performance cars, any part that needs to be rigid and strong but lightweight. Carbon fiber has been a common go-to material. A lot of race cars nowadays don't have metal chassis. It's all made of this material. It's almost magic until you understand what's behind it. Carbon fiber, its characteristic is to be very rigid, very hard, very strong. Now, carbon fiber is made in a process where synthetic materials are heated and they go through some complex procedures to create this very durable material. Carbon fiber is extremely high in tensile strength. Tensile strength is that ability to withhold and withstand stresses trying to pull it apart. So even a small fiber such as this one takes a tremendous amount of pressure to cause it to break or part. Well, if I incorporate all these fibers in the right orientation, then I can create a very strong, lightweight, rigid part. So carbon fiber, very common and an awesome material. And the last material I want to look at in the fiber side of the three parts of composites is this material here. Now, most people are aware of this material, but very few people know about it from the aviation point. Most people understand what this is based on bulletproof vest. This is Kevlar. Kevlar can always be identified by its color. This gold color is natural. That's not anything added as a dye. That's the natural color of the material. But Kevlar is a name brand given to this fiber by DuPont, the chemical company. Kevlar is actually known as aramid fiber. So very stretchy. That's its key component, its key desirable characteristic is the fact that Kevlar can stretch a long way before the fiber breaks. Now, if you compare Kevlar to carbon fiber, rigid, but when I think of rigidity, I also think of being more brittle. When I think of Kevlar, I think of stretchy materials. That's the reason it is such a good material to build body armor and bulletproof vest out of, is because it'll stretch and yield a lot before the fiber breaks. Therefore, it absorbs the energy to stop the bullet. That same characteristic can be a really cool characteristic when we're building parts for aircraft. Oftentimes, we need a material with a blend of characteristics to do one job. It must be strong, rigid enough to hold its shape, yet flexible enough to give so that it doesn't break or crack. So oftentimes, that's why in advanced composites, you'll see all three of these materials combined to get those best characteristics so that we can create that super part out of a composite material. That's the first of three parts of the typical composite material. The second part I would like to talk about is the matrix system. And no, we're not talking about Neo and the code, although understanding code is an important part of our business. When I say matrix relating to composite parts, what I'm talking about is the resin that binds these parts together. As you can see, these fibers are very loose, very pliable, very flexible. That wouldn't be desirable to build a wing out of. However, when we combine these with the matrix or resins, it creates a stiff, strong, very resilient part. The matrix system that we use in aviation is a little different than the systems that used to be used to do fiberglass only work. When it comes down to these matrix or resins, really there's two overall systems that we need to understand a little bit about to be fully functional in this particular technology. You've got polyester resins, which were commonly used in fiberglass, and if you've ever repaired a boat or patched fiberglass on anything, say you run down to Lowe's, Home Depot, local supply house, often what you're buying is polyester resin. Now, one easy way to determine if it's a polyester resin compared to the resins we use is it stinks. Polyester resins have a very strong, disagreeable odor often, and polyester resins are also the resins that some people have allergies and sensitivity to. So if you're doing boat repair and you're using a polyester resin, well, that's appropriate. That would be what you would use. But always remember, when handling these resins, they're a chemical, and chemicals tend to be harmful, especially over time. So when working with any resin, the safety is gloves, eye protection, and respirator when you're dealing with these polyesters. Very strong chemical. Now, the resins that we use for aviation composites tend to be epoxy based. And epoxy is a term that a lot of people have had exposure to because we use it in the form of an adhesive. Most of us, especially us southern folks, just call it glue. An epoxy glue is a two-part that you mix that is a very good, very effective glue. Well, it's a similar base that we use in the resins to join these. So an epoxy-based resin is a little less volatile. When I say volatile, I'm talking about a chemical's ability to change from a liquid to a gas. Well, what does that mean, volatility? Well, lower volatility tend to be more stable, less apt to create fumes that would be hazardous to your health or irritating. That's the side we use in aviation. So just keep in mind, now there's many brands made by many manufacturers. You would always consult your structural repair manual to make sure you're choosing the right fibers and the right matrix system or resins. But the resin's job is simply to coat these fibers, hold them closely together in the shape that we desire. Note this, resins do not add strength to the part. The true strength of the part comes from the fibers that we're bonding together. The resin's job is to hold them in position and transfer stresses quickly to these fibers. And resins must be mixed accurately and carefully. They must be applied in the appropriate amount of time, and they must be allowed to cure at the right temperature under the right pressures. So the resins or matrix system, second big component, serves a very important job within these composite parts. Now, the last part, part 3 of these composites that I'd like to discuss with you is the core materials. Core materials are very important, and I'm going to grab some core material and I will be right back. I forgot.